Right, so we have an analog ammeter. We're told that it has a maximum current of, or it measures a maximum current of 1 milliamp, and it has a resistance of 18 ohms. And this is the circuit that represents our ammeter. We're told that if we add a resistor, the shunt, in parallel, then we can measure a larger current. So this is the resistor that we add in parallel. And it also says in the question that the ammeter is represented by the 18 ohm resistor. In the bit below, so the maximum current through the 18 ohm resistor remains as 1 milliamp. So we have a current of 0.001 amps going through that resistor. And we're trying to show that the resistance of the shunt needs to be about 0.01 ohms to allow this ammeter to measure a maximum current of 2 amps. So what we can do, if we want to work out the resistance of the shunt, we can start off by working out the voltage of this or across that component, and we can do that by using the equation V is equal to IR. So then get the current, multiply that by the resistance, and we end up with a voltage of 0.018 volts. So that is the voltage across the resistor, or the ammeter, 0.018 volts. And because this resistor is in parallel with the shunt, they will both get the same voltage. So you'll have 0.018 volts across the shunt as well. And then we can work out the current by considering that we have 2 amps here. That 2 amps splits into these two branches, this one and this one. So then we can do 2 minus the 0.001. We get 1.999 amps. So that is the current going through here. And then finally, we can use these two values to then work out the resistance. So we can do V is equal to IR again. Resistance is equal to voltage divided by current. So for the shunt, the voltage is 0.018. And the current is 1.999. And then we end up with the resistance being 9.00 times 10 to the minus 3 ohms, which is the same thing as 0.009 ohms. And that is approximately 0.01 ohms. So for the next part, we're trying to work out the length of this wire required to make the shunt. We have the radius, 0.95 millimeters. So it's this in meters. We have the resistivity. So this seems like a pretty straightforward standard question. We want to work out length, and then we worked out the resistance earlier. The resistance was the 9.00 times 10 to the minus 3. Okay, so then we can use the equation resistance is resistivity times length over area. Area is pi r squared. That's the cross-sectional area of the wire. And then the length will be pi r squared resistance all divided by resistivity. And then we put that into our calculator. So this would be pi multiplied by 0.95 10 to the minus 3 squared divided by, times by the resistance, which was 9.00 times 10 to the minus 3, and then divided by the resistivity, 4.55 10 to the minus 7, and we end up with 0.0561 meters, or to 2 sig figs, 0.056 meters.